judges. We're here to give you a short presentation on our solution to the challenge waste. We came up with a system that combines the power of two robots, a trash bot and a smart dumpster. The trash bot contains two modes, the collection mode and the bin mode. And this is how it works. In the bin mode, the trash bot will remain stationary in a particular location in a classroom or any location with a front hatch open to act as a normal trash bin. Students find it mostly inconvenient to walk over to the trash bin in order to dispose of it. So we came up with a basketball-like plank to make it easier and more fun for students to dispose their trash. In the bin mode, it remains stationary in the location. But then once it enters collection mode, which will be after school, the robot will then accumulate all the waste around it and in the school's environment. Then it transports that waste to our smart dumpster, which will then send an SMS to the waste management on the waste accumulated for that day.
Waste. Waste is any substance that is unwanted or unuseful. Waste is any discarded substance that materials don't function anymore. Waste in any form, liquid, solid, or gas, although generally waste is solid. There are various types of waste like unwanted food, torn clothes, kitchen waste, etc. For the purpose of this research, these purposes are defined as giving rise for four major categories of waste: municipal waste, industrial waste, agricultural waste, and hazardous waste. But the main waste we see in schools are municipal solid waste. And then there are now ways to reduce waste, which is to use a reusable bottle or cup for beverages on the go. Use reusable grocery bags and not just for groceries. And then purchase wisely and recycle. Compost it, and also to avoid using single food and drink containers and utensils. Buy second-hand items and donate used goods. Also shop local farm markets and buy in bulk to reduce packaging. Curb your use of paper, receipts, and magazines. Then, for the first challenge we have for our robots, students find it easier to toss litter aside than to walk all the way to the trash bin, especially in a very large class. Our trash bots, with its basketball-like board, will encourage sporty students to at least try and aim at the hoop, which will reduce the amount of litter in the class or the environments the class case may be. And for our research and learning purposes, we did an interview with in total of 10 students, 8 selected and 2 other students, about the trash bots from each set in our school, from SS1 to SS3, with the following table put up. People who like the idea of the basketball style bin were about 64% of the interviewed people, while people who did not like the idea of the basketball style bin were 12%. But people who liked the basketball style bin but wanted additional features were about 24%. After the completion of all the results of the interview, it was agreed that basketball style bin was decided for the final design of our robots. And then next, this is the robot design at all angles. From the left, you see the standard design of how it should be in collection mode, moving around with the threads, which will now use its pincers to scoop up any trash and then put it into its basketball-like trash bin at the back. And then if you go down to the right, you see the back view where we see the servo which will now open a hatch behind the dustbin for it to empty all trash into the dumpster. Next slide, please. Okay, then this is all the circuitry we have been able to accumulate for the robot's design. We use about five servos, 7 ultrasonic sensors, 1 Arduino board, and 2 motors. Two of those 5 servos will be in a gimbal-like formation, which move on X and Y axis to be able to move the arms to pick up the trash and put inside the dustbin. The motors will act as the wheels, which will now move the threads for it to act in tank-like steering to move back and forth. And the reason we decided to go with threads instead of wheels is because that threads can move over more rough terrain than what wheels can traverse over. And the sensors are to determine the difference between walls, objects, and trash, also staircases. Next is the cost implications. For the Arduino Uno, we have just one unit cost 12,000, while for the micro servos, just 5 units will cost 10,000. For the ultrasonic sensors, just 14,400 for each of these. For all of these, and then for the gear motors, we have just 2 units for 2,000. All of this together will result in about 38,000. And then our impact on society. Poor waste management can lead to a lot of problems, including land pollution, air pollution, global warming, and climate change. Our robot, in its own little way, will contribute to the reduction of the amount of land pollution in society, which will in turn help reduce all the above problems. And then for our references, we use tinkercad.com to design the robots and also to design the circuitry. And we use allaboutwaste.com, nature.com, how recycling bots are transformed the waste management industry, how AI robots and waste management control, and then home waste robots to help us with our research on how to effectively decide on our robots and how it will help society. Thank you.